Here we go with our SPSS file to conduct the one sample t-test. So we have only one variable here, which is the marks in current year. Our null hypothesis is that there is no change in the average marks in the current year compared to last year, which was 60. So the H naught is mu is equal to 60, and the alternative is mu is not equal to 60. And this is a two-tailed test. Our primary assumption is that there had been a special training program this year which was aimed at improving the marks in the current year compared to last year. So we are testing whether the program had any effect on the marks in the current year. So accordingly we have set our null and alternative. Null is mu equal to 60, that means there is no change in the population mean compared to last year, and alternative is there is a change in the population mean, that is mu is not equal to 60. So here we go, analyze, compare means and take one sample t-test. So the marks in the current year is taken into the test variable. Actually I have already done this before, so that's why it's already there. So otherwise it would have been like this. So we take the marks into the test variable box and we set the test value to 60 because our H naught is 60 is what is being tested, and go to options. So we leave it by default 95% and click continue and click OK. It's a pretty simple test. So click OK. So the SPSS gives us this output. These are the descriptive statistics. So N51 is that our sample size is 51. Then the sample mean is 63. The sample standard deviation is 9.26. And based on these two values, the standard error would have been calculated as S by square root of n. Yeah, based on these two values, standard deviation and sample size. The standard error would have been calculated, and based on the standard error and based on the sample mean and based on our null hypothesis that mu is equal to 60, t statistics would have been computed by SPSS with degrees of freedom 50. So this degrees of freedom 50 has been arrived by n minus 1, that is 51 minus 1 is degrees of freedom for this test. And then of course we have other confidence intervals which we will not be discussing now. And mean difference is of course the numerator in the t statistic, that x bar minus mu. So x bar is 63 here, mu is 60, so you have a mean difference of 3. And the most important part of this output is this labeled as significance value two-tailed 0.025, which is popularly known as p-value. So the p-value for our study is 0.025, and you've been taught in a statistics class while interpreting SPSS output, it's pretty easy to decide whether you reject H naught or fail to do so by comparing the p-value with your set significance value, which is alpha. So for our study, let us say the alpha is 5%, so then alpha is 0.05. So as the p-value, which is 0.025, is less than the alpha that we have set, 0.05, we reject H naught. So the H naught here was that mu is equal to 60, that is being rejected, and we conclude that mu is not equal to 60, which when translated into plain English shall mean that there had been an effect of the special training program on the marks scored in the current year.